Welcome to this M1 video on static particles. So a particle or rigid body is in static equilibrium if it is at rest and the resultant forces acting on the particle or rigid body is zero. And that's what we're looking at here. So to solve these problems, you need to start with a diagram, resolve forces either into the horizontal and vertical or parallel and perpendicular if it's on an inclined plane, and then sum the components and set them equal to zero, or one direction equal in the other direction, and then solve the resulting equations. Simple. Now in reality there is, I would say, nothing really new to you here. It's just looking at kind of different types of questions, but I wouldn't say this is anything really that new to you. Okay, you shouldn't have too much of a problem with this video and with, in fact, this next couple of videos. But we'll go through it following the textbook so that you're able to follow it as you're learning in school. So without beating around the bush, let's get into the first example. And here we have it. So the diagram shows a particle in equilibrium under the forces shown. By resolving horizontally and vertically, find the magnitudes of P and Q. Obviously this kind of thing it won't say in an exam. That's just put in there by me for this question. So let's start with the diagram. So I want to resolve horizontally and vertically. So let's start with this P. So P cos 30. And then vertically it'll be P sine 30. And then for this 8 Newton one, it will be 8 cos 45, and vertically it's going to be 8 sine 45. Okay, and then Q is already vertical, so we don't need to worry about that. Now, once I've done that, then I need to resolve both horizontally and vertically. So if I look vertically first, sorry, I moved that too far over. So let's resolve vertically first. I've got 8 sine 45 plus P sine 30, and then really it is minus Q equals 0, but I just find it easier to write it like that because they're balanced, so the ones going up is equal to the ones going down. And obviously we've got two unknowns in this. So let's now resolve horizontally, and I've got 8 cos 45 equals P cos 30. Okay, so from this, it's nice and straightforward. I can use this equation to find out what P is, and then substitute it into this equation and find out what Q is. So P equals 8 cos 45 divided by cos 30. And that is 6.53 newtons to 3 significant figures. And I will store that as A, so I can use the full answer in my next step. So my next step is to find Q. So Q is 8 sine 45 plus P sine 30. So this answer times sine 30 plus 8 sine 45, and I get the Q is 8.92 newtons to 3 significant figures. Okay, so it's very, very easy. Now, with this kind of question where I've got 3 forces, I can also do it with a vector diagram, okay, but only because I've got 3 forces. So these 3 forces will form a closed triangle. So if we call this method 1, and what I'd say is the preferred method, method 2 you can use in certain scenarios. So method 2 would look like this. This would be my P. My Q would be straight down. And then my 8 Newton one would be like that. And now all that's left to do is find my angles. So between the 8 and the Q is 45 degrees. Between P and Q, like this one, is going to be 90 plus 30, so 120. So this is 60. And then all I've got left there is 75 degrees. Okay, so once I've got this, then I can use the sine rule, can't I? So, you know, to find P over sine 45 is equal to 8 over sine 60. And I can rearrange that. And Q over sine 75 is equal to 8 over sine 60. And P is 6.53 newtons to 3 significant figures. And then 8 over sine 60 times sine 75. And we get the Q equals 8.92 newtons to 3 significant figures. So you can see when I've got just 3 forces, I can use this method to quickly solve them. Okay. And another variation on this method would involve you not even needing to put it into a triangle. So, you know, this, if I've got 3, let's do 3 forces, similar to what we've got here, A, B, and C. And this one is alpha, this one is beta, and this one is gamma. Then A over sine alpha equals B over sine beta equals C over sine gamma. Okay, and these then also work. So if I apply it to, you know, this problem here, I've got basically 8 over sine, now this is going to be 120, the 30 plus 90 here. I've got P over 135, so P over sine 135, and I've got Q over sine 105, because that's 45 and 30 is 75, so this has got to be 105 in between. And again, now if I work these out, so P is going to be 8 over sine 120 times sine 135 times sine 135. And again, I get the right answer, so 6.53 newtons. And Q will be 8 over sine 120 times sine 105. So 8 over sine 120 times sine 105. And again, it's correct, 8.92 newtons. Okay, so you can use this rule. This is known as Lamy's theorem. I'm probably butchering that, but that's what it's known as. So this rule will mean that you wouldn't even have to put it into a closed triangle. You could just solve it straight like so. Okay, and that is really just for use when you've got three forces. Any more than three, any less than three, and you have to resolve. So I suppose in overall thinking about it, it's best to learn how to resolve, and then, you know, for those of you, you know, kind of a bit more able to remember it and to enjoy maths, will want to learn this method, just because then you can speed up certain problems. Right, let's have a look at the second example. Okay, we've got a diagram showing a particle in equilibrium on an inclined plane. Forces are shown. Find the magnitude P and the angle alpha. So for this, we need to resolve parallel and perpendicular. So that is P cos alpha that, P sine alpha that way, and then I've got 12 cos 30 there and 12 sine 30 that way. Okay, so that is my resolving done. Now what I need to do is resolve parallel perpendicular. So let's look at that. So let's do parallel first of all. So going up the slope, I've got P cos alpha. Going down the slope, I've got 12 sine 30 plus that 7 newtons down here. And then resolving perpendicular, I've got P sine alpha plus 4 equals 12 cos 30. Now, if I rearrange this second equation to take the 4 to the other side, then what I've got is equation 1 and equation 2. And 2 divided by 1 will get rid of my p's. So P sine alpha over P cos alpha is 12 cos 30 minus 4 over 12 sine 30 plus 7. The p's will cancel, and sine over cos is tan. So tan alpha is 0.4917 and so on. Shift tan to get the inverse, to get what alpha is, gives me 26.2 degrees to 3 significant figures. Now I'll store that as 8 because then I can use it. So using equation 1 or equation 2 now to find P, I'll use equation 1. So from 1 we got P cos alpha equals 12 sine 30 plus 7. So P is 12 sine 30 plus 7 divided by cos alpha. And of course we know what alpha is now, don't we? So 12 sine 30 plus 7 divided by cos of 8, because that's what I stored it as, and we get the P is 14.5 newtons to 3 significant figures. And that is now both P and alpha found. Okay, obviously I could have used equation 2 as well, but in cases like this, you know, using the sine over cos is equal to tan, and then, you know, obviously the p's cancelling is a good way to narrow down and get just to the one unknown. Okay, so hopefully you found that quite easy. I think it is, because I don't feel like it's really anything new. The statics of a particle, it feels static particles, they just feel like it's more of stuff that we've already done, at least at the moment. But I digress. So don't forget to hit that subscribe button if you're yet to subscribe to my channel. Smash the like button if you found any of this video useful, and hit that join button if you're willing and able to help me out financially. Otherwise, let's look at the questions. So just two quick easy questions here for you. Question 1 I've just done in 2 parts, one with 3 forces and then one with more than 3 forces, and then question 2 is just an inclined one. Okay, very straightforward. Pause the video now. Okay, welcome back. Let's have a look at the answers. Okay, let's resolve. So P cos theta, P sine theta, and it's also 15 sine 25 and 15 cos 25, 12 cos 40 and 12 sine 40 that way. So we've got resolving horizontally, we've got P cos theta plus 12 sine 40 equals 15 cos 25, and resolving vertically we've got 15 sine 25 plus P sine theta is equal to 12 cos 40. So we'll take both of these. I'm just going to move this one down and we'll rearrange them. So rearranging this one, we get P cos theta equals 15 cos 25 minus 12 sine 40. And then this second, we'll call that equation 1. And this one, P sine theta, is 12 cos 40 minus 15 sine 25. And we'll call that equation 2. Now I just do equation 2 divided by equation 1. So P sine theta over P cos theta, and 12 cos 40 minus 15 sine 25 over 15 cos 25 minus 12 sine 40. The p's will cancel and that gives me tan theta equals 0.485. We're not to 3 significant figures there. Shift tan, and we get that theta is 25.9 degrees to 3 significant figures. Now substitute then that into either 1 or 2. So I can go, from 1, P equals 15 cos 25 minus 12 sine 40 divided by cos theta, and that gives me 6.54 newtons to 3 significant figures there. Okay, so that is how to solve this one. Now, it is also a 3-force one, so you could complete a triangle, although where the value of theta is, I think that might make things a little bit harder. Okay, so I just resolved anyway, because that's, the habit that I'm in. Anyway, let's jump into part B. So let's go ahead and resolve. So I'll start with this one down here. So 15 cos 20. And across will be 15 cos 20. Then let's look at the P. Going across will be P cos 50. And up will be P sine 50. Now the 11 newtons going up will be 11 sine 30. And going to the right will be 11 cos 30. So I've sorted out my forces. Let's look at the equations now. So going left we have P cos 50 plus 15 cos 20. And going right we have Q plus 11 cos 30. And then when we resolve vertically, we've got going up P sine 50 plus 11 sine 30. And going down, we've got 15 cos 20. So from this second equation, I can go ahead and work out what P is, can't I? Because that is going to be 15 cos 20 minus 11 sine 30 all over sine 50. And that gives me that P is 11.2 newtons to 3 significant figures. And as always, I'll store that as A. Now we can use the second equation, or this first equation here really. So from 1, we've got P cos 50 plus 15 cos 20 minus 11 cos 30, and that equals Q, doesn't it? So Q is 11.8 newtons to 3 significant figures there. So both actually fairly even forces, but obviously one's at an angle there. But either way, that is now one part B done. Let's have a look at question 2. So here we have number 2, and what we want to do here is resolve both parallel and perpendicular to the slope. So first I'm going to start off with this 12 Newton force. So that's going to be 12 cos 30. And then parallel will be 12 sine 30. Now Q is going into it, so I'll do this one in just blue, just replace Q to the other side there, okay? And then you can see that this is the 30 degrees. So that Q is going to go in up the slope, and this will be Q cos 30. And then perpendicular to the slope will be pointing down, and it'll be Q sine 30. So let's resolve parallel first of all. So going up the slope we got Q cos 30, and going down the slope we got 12 sine 30. So from this I can find out what Q is. And Q is, well, it's 4 root 3 newtons, or 6.2, oh no, 93, sorry, newtons to 3 significant figures. Okay, I'll store that as A in case I need it coming up. Now let's resolve perpendicular. So pointing up we have P, and then down we have 12 cos 30 plus Q sine 30. Okay, so I've already got Q in my calculator, so times that by sine 30 plus 12 cos 30, and I get 8 root 3 newtons, or 13.9 newtons to 3 significant figures there. So those are my two answers for P and Q. It's a very straightforward question. Okay, hopefully you got the answers out. Now, it was a fairly straightforward, I think, video. Like I said, I feel like this is a lot of stuff that we've already done. Okay, now stay tuned for the next video, which will show up at the end to click on. Otherwise, I'll see you in one of my other videos.